Scientists are now measuring how fast your body is aging. They are removing so-called zombie cells and testing drugs that may slow parts of the aging process itself. Here are the 5 biggest longevity breakthroughs of the last 5 years. Number 1, biological age clocks. For most of human history, age was simple. If you were born 50 years ago, you were 50 years old. But scientists now know that 2 people can have the exact same chronological age while aging at dramatically different speeds. One 50-year-old may have the health, fitness, and disease risk of a typical 40-year-old. Another may already resemble someone who is biologically 60. This realization led to one of the most important breakthroughs in longevity science: biological age clocks. These tools use DNA methylation patterns and other biomarkers to estimate how fast your body is actually aging. Instead of asking how old you are, scientists can now ask a much more important question: how fast are you aging? This changes everything. For decades, researchers struggled to determine whether anti-aging interventions were actually working. Now they can measure changes in biological aging directly. This breakthrough has accelerated longevity research around the world and is helping scientists evaluate everything from diet and exercise to medications and supplements. For the first time, aging itself can be measured. And if something can be measured, it can potentially be improved. Number 2, GLP-1. When Ozempic first appeared in the news, most people viewed it as a weight loss drug. But researchers quickly realized something surprising. The benefits appeared to go far beyond body weight. Patients using GLP-1 medications often experienced improvements in blood sugar control, inflammation, cardiovascular health, and metabolic function. This raised an important question. What if these drugs are affecting some of the underlying mechanisms of aging itself? Scientists are now actively studying GLP-1 medications as potential longevity interventions. That interest exploded after large clinical trials showed significant reductions in cardiovascular events among people receiving semaglutide. This was a major moment because heart disease remains one of the leading causes of death worldwide. Researchers still don't know exactly how much the benefit comes from weight loss and how much comes from other biological effects, but one thing is clear. GLP-1 drugs have become one of the most important areas of longevity research. Many experts now believe these medications could become part of future strategies designed to extend health span, not just reduce body weight. Before we move to number 3, if you're enjoying the video, hit the like button and subscribe to High Longevity. It really helps the channel. Now number 3, senescent cells. Imagine a worker who stops doing their job but refuses to leave the office. Not only are they unproductive, but they start creating problems for everyone around them. That's essentially what senescent cells do. These cells become damaged and stop functioning normally. Instead of dying and being removed by the body, they remain in tissues and begin releasing inflammatory molecules that can damage surrounding cells. Scientists often call them zombie cells. As we age, these cells accumulate throughout the body. Researchers now believe they contribute to many age-related diseases and may play a central role in the aging process itself. This led to one of the most exciting discoveries in modern longevity science. In animal studies, removing senescent cells improved physical function, reduced disease burden, and in some cases, even extended lifespan. Scientists are now developing compounds known as Senolytics. Their goal is simple: find ways to selectively remove zombie cells while leaving healthy cells untouched. Although human research is still in the early stages, many experts believe Senolytics could become one of the most important anti-aging therapies of the future. For decades, aging seemed impossible to target. Now scientists are exploring the possibility of literally removing some of the cells that drive it. Number 4, taurine. In 2023, a molecule called taurine suddenly became one of the most discussed topics in longevity science. Taurine is a naturally occurring amino acid found throughout the body. It plays important roles in metabolism, cardiovascular health, mitochondrial function, and cellular protection. Researchers noticed something interesting. Taurine levels tend to decline with age. This observation led scientists to ask a simple but powerful question. Could restoring taurine levels help slow aspects of aging? Animal studies produced surprising results. researchers observed improvements in metabolic health, muscle function, immune system performance, and overall health span, meaning the number of years you live in good health. In some animal models, lifespan also increased. The findings generated enormous excitement. At the same time, scientists remain cautious. Human aging is far more complex than aging in laboratory animals. While taurine is one of the most promising compounds currently being studied, researchers still need larger human trials before drawing firm conclusions. But the discovery highlighted an important shift in longevity science. Instead of simply treating diseases after they appear, scientists are increasingly looking for biological factors that influence aging itself. Taurine may turn out to be one of those factors, and if future studies confirm these findings, it could become a major tool for healthy aging. Number 5, rapamycin. If you ask many longevity researchers which drug has generated the most excitement, one name often appears near the top of the list. Originally discovered in soil bacteria, rapamycin was first developed as an immunosuppressant, but researchers eventually noticed something remarkable. In multiple animal studies, rapamycin extended lifespan. The reason appears to involve a pathway known as mTOR. Think of mTOR as a biological growth switch. When activated, cells prioritize growth and reproduction. When activity is reduced, cells shift more resources toward maintenance, repair, and stress resistance. Many scientists now believe excessive mTOR signaling may contribute to aging. Rapamycin partially suppresses this pathway. In multiple animal studies, this intervention extended lifespan and improved markers of health. Even more impressive, benefits were observed when treatment started later in life. This is one reason rapamycin has become such a major focus of modern longevity research. Human studies are still ongoing, and researchers are working to determine the safest and most effective dosing strategies. But among all currently studied longevity compounds, rapamycin remains one of the strongest candidates for influencing the biology of aging itself. The science of aging is advancing faster than ever before. Biological age clocks are helping scientists measure aging directly. GLP-1 medications are revealing unexpected benefits beyond weight loss. Senolytics are targeting zombie cells that accumulate with age. Taurine is opening new questions about age-related biological decline, and rapamycin continues to challenge long-held assumptions about what is possible in aging research. Just a few years ago, many of these ideas seemed impossible. Today, they are among the most active areas of scientific investigation. The question is no longer whether aging can be influenced. The question is, how much? And the answer may completely change the future of human health. If you enjoyed this video, make sure to subscribe to High Longevity and join us for more science-backed insights into living longer, healthier, and better. Thanks for watching, and I'll see you in the next video.